Hi to all. I am Gurumurthy, working as an associate professor from KPR Institute of Engineering and Technology, Coimbatore. Today I am going to explain how to design full wave rectifier with and without filter using multisim simulation software. Before going to see the simulation, we should know what is by off wave rectifier and full wave rectifier. So PN junction diode is mainly used in power supply unit to convert an alternating current into direct current. The process of converting AC to DC conversion is called as a rectification, and the AC to DC conversion circuit is called rectifier. Basically, there are two types of rectifier circuits are available, namely off-wave rectifier and full-wave rectifier. In off-wave rectifier, the single diode is used for rectification and thus it conducts for only one offset. On the other hand, the full wave rectifier conducts for both positive and negative off cycles of the input AC supply. In order to rectify both the off cycles of the AC input, the two diodes are used in this circuit. The diodes feed a common load resistance with the help of center tap transformer. The rectifier circuits give the pulsating DC, and this pulsating DC output is also called the ripple. So generally the ripple is undesirable, but thus it should be smoothed by the using some filter. The ratio of the effective value of AC component to the average DC value is called ripple factor. The ripple factor should be less for the better rectification. The theoretical value of the ripple factor for off wave and full wave rectifier are typically 1.21 and 0.8 respectively. To design a full wave rectifier, we need the following component. First one is the center tap transformer, resistor, diode, AC power source, ground, capacitor, and finally oscilloscope. Capacitor is required for with filter. So without filter, it is not required. Let me start. First, I need to select the component. So select the component from this option. First, we are going to select the AC source. Next one is the ground, also paste it here. Next, I am going to choose center tap transformer. You can see there will be two options here, right? So here we need tap transformer. So you can select the second one. So select and click OK. Then you can paste it here. Next we need one diode. So you can diode also you can select from this component. So we are going to select 1N4007. Click OK and paste it here. Next, I need two more diode, right? So I'm going to paste it here. So next component is I'm going to choose the one resistor. So I'm paste it here. Next one is and I need some oscilloscopes. You can select from the right hand side, right? So it has two terminals. So let me adjust for better connection side. First I'm going to connect power source with the primary coil. So one end to the power source, another end also is the primary winding coil. Secondary winding coil I'm going to connect one end with the diode, right? So let me adjust, right? Okay, fine. Then another end, right? So secondary coil, another end also connected with the second diode, right? Then I'm going to resist in terms of parallel connections. So rotate 90-degree phase. So in that I need to short circuit the two diode component end. Then output terminal should be connected with the one end of the diode. Then output terminal, another terminal is also connected with this center tap transformer. Okay. Then finally, I need to connect the resistor with this two diodes, right? Let me connect like this. Okay. Then finally the ground should be connected here. Okay. And then now another term channel from this oscilloscope I'm going to connect it with the primary coil. Okay. One into the primary coil with both ends. Okay. Then next one is the you can see, in order to differentiate the input output, I'm going to make some color option, right? Here I'm going to say blue for output signal. So you can easily differentiate. Okay. Then resistor values also, as per the requirement, I'm going to change to the 100 kilo ohm. Okay. Then here you can see this, right? So it is the transformer, but we are using saturated transformer. But here I am having only a normal transformer, right? So the winding ratio should be 10:5:5. 10 means one is the primary winding coil, is the secondary side I am having 5:5. That means 10 also. But I need some step down transformer. I'm going to change the winding ratio. So click here. You can change the primary coil as to 10:100 and click OK. Then you can see it here, right? So here I have converted into step down transformer, right? So primary winding is the more is when compared to the secondary winding coil. Okay. Then now I'm going to make it as I'm going to run the component, right? So you can go to run the simulation. Just click the oscilloscope. You can see the output. You can see some modification to view the output properly. So you can see it here, right? Here red is shows the input signal, blue color is shows the output signal. So here passive cycle also is conducting the. So as I said before, full wave rectifiers connect both positive and negative cycle. Right? So this is I am getting some pulsating DC signal. So, but I need to get a smooth. In order to suppress the pulsating DC signal, I need to use the filter. So I am going to add one filter component here. Let me stop the simulation. I am going to select one capacitor. The capacitor from this component, I'm going to paste it here. It should be so capacitor also should be in parallel connections, right? So I'm going to connect the capacitor in this secured places, right? Let me rotate 90° clockwise to make it as the parallel connections. So I have connected here. Then let me check, right? So this is the output of. So as I said before, full wave rectifiers connect both positive and negative side. Right? So this is I am getting some pulsating DC signal. So, but I need to get a smooth. In order to suppress the pulsating DC signal, I need to use the filter. So I am going to add one filter component here. Let me stop the simulation. I am going to select one capacitor. The capacitor from this component, I am going to paste it here. It should be so capacitor also should be in parallel connections, right? So I'm going to connect the capacitor in this secured places, right? Let me rotate 90° clockwise to make it as the parallel connections. So I have connected here. Then let me check, right? So this is the output of the full wave rectifier with filter. You can see this result of this full wave rectifier with filter. Okay. So I hope you understood the concept about how to design a full wave rectifier with and without filter using Multisim simulation software. Thank you for watching. The full wave rectifier with filter. You can see this result of this full wave rectifier with filter. Okay. So I hope you understood the concept about how to design a full wave rectifier with and without filter using Multisim simulation software. Thank you for watching.